My name is Mark Regan, and I'm the product manager for retail AI and machine learning solutions. So we've got a really packed agenda today. Retail's been an area of intense focus for Google over the past couple of years. You'll have seen from Thomas Kurian's keynote on Tuesday that 7 out of the top 10 retailers are now building and innovating on GCP. And we're really proud to be working alongside them to be tackling a wide variety of problems for the retail industry, whether that be their supply chain, their omni-channel commerce experience, or store operations. The list goes on. But for today's session, I wanted to focus on machine learning use cases within retail. That's the area that my team focuses on specifically. And we're really excited on behalf of many engineers and product managers to be able to share with you 4 new product announcements that are relevant to retail. And these are AI-enabled products that are truly transformative. I'm also really proud to be joined by 3 incredible companies that we've been partnering with closely over the past couple of quarters. That's Nordstrom, the Walt Disney Company, and Pitney Bowes. They're going to come on stage and share with you their story of how they've been using these AI products to transform and innovate within their own companies. I think everybody here who works within retail lives and breathes the fact that we're going through a period of transformation, a difficult time in retail, for sure. And at the core of this, the consumer is really driving a lot of the change. Their expectations have never been higher. And that impacts everything across your value chain, whether that be your supply chain, the type of omni-channel commerce experience you need to deliver, even the store experience. They're expecting a personalized, engaging shopping experience. So I really think this is an exciting time, but it's also an incredibly difficult time. And that's what makes it so exciting for me, because when I look at this retail value chain behind me, I am convinced deeply that machine learning and AI will transform every single aspect of this value chain over the next 5 to 10 years. Businesses will be built and torn down based on that innovation, and that's incredibly exciting. But I want to be very concrete. Instead of focusing on the 5-year or 10-year, what has Google built today with our customers and our partners that you can start using to innovate within retail? And so there's 4 products that I'd like to tell you about. The first is Contact Center AI, then Visual Product Search, Recommendations AI, and AutoML Tables. So let me dive straight in. We all work within retail, and we recognize that every customer interaction is a really precious opportunity. Opportunity to give a great experience, to build loyalty, build brand. And I think the call center is that unique place where someone is super stressed out, has a big problem, and they need it solved. Within Google, we recognize that machine learning and AI could provide a huge amount of value there. And so we've built an AI agent that you can deploy inside of your call center. So when your customer calls in, the phone is answered immediately. No more dial pad numbers that you have to press. And you can converse with that agent in a natural language, ask questions. The agent can talk back. It can have follow-up questions and move you through that decision process so that you can close out the case quicker and have higher satisfaction. Now, you may ask, what if the issue becomes very complex? Not every issue is simple. Well, we gracefully hand off the call to a support rep within your call center, and they can close out the case. So I think this is truly a transformative capability, and we're only at the beginning with regards to call center. We've integrated with some of the biggest vendors in the market, so if you're interested, call your contact center provider and ask them when they're integrating with Google's Contact Center AI. The second product is Visual Product Search. We've been, I think, very fortunate within Google to have experienced many consumer behavior changes over the period of our company's history. As an example, we started off as a text-based search engine, and we saw a big emergence of voice being a key modality that people wanted to search on. Well, today we're seeing a new emergence that customers want to be able to search by taking a photograph. And we're particularly seeing this within young millennials and certain verticals around apparel, fashion, home goods, and CPG. The product that we're announcing today and that we're launching will enable you to build a custom computer vision model using your own product catalog so that your developer can deploy this feature within your mobile phone app, enabling your customers to have unique experiences like you can see on the screen behind me. The third product I'd like to mention is Recommendations AI. We hear from customers and from the retailers that we work with consumers are demanding an engaging and personalized experience. That's what they want. And they want that across every channel that they're working on, be it online, in-store, through all the different marketing channels. This is a hard problem, and we've been working deeply on this within Google for years. All of our products that you see, Search, Geo, YouTube, Play, have personalization and recommendation deeply embedded within it. The product that we're releasing today is the externalization of all of that research and capabilities so that you can train your own custom personalization recommendation model for your customers using your own data. We've been running benchmarks against many competitors in the market for the past year, and also against internal data science teams within retailers. And across the board, we've been seeing dramatic increases in these key KPIs that you see behind me. The fourth product I'd like to mention is called AutoML Tables. Within retail, I think we'll all accept the majority of the data we're dealing with is structured data. That means it lives in tables. Transactions, product catalog, pricing. This is the fuel that machine learning models need to build. Models such as customer lifetime value, propensity to buy a certain category. How likely is this to be a fraudulent transaction? And the list goes on. There is dozens and dozens of machine learning models that can be built using data within a retailer's org. The product that we're building, or that we're announcing, AutoML Tables, will enable your analysts and your developers and engineers to build state-of-the-art machine learning models without having to write any machine learning code. So in my experience, there's usually 10 or 100 times more developers and analysts in a company than there are data scientists. So we're trying to unlock the 99%. I'm really excited to see all the different use cases you can tackle here today. So I'd like to invite on our first speaker for today from Nordstrom. John Xiao is Vice President of Technology, leads a variety of different activities, one of which is creating new, engaging shopping experiences using computer vision. So please join me in welcoming John to the stage. The green button.
Thank you, Mark. Last year, I did a little experiment with my teams at Nordstrom. This is a product that we actually sell on our website. I show this product to my teams and ask them to come up with a set of search keywords. And their objective was to use the search keywords to boost this product to the top of search result. Initially, we just came up with a very simple keyword, blue blouse. And that's what we got on the search result. Not even close. That's because this product is supposed to be wrap top. So we changed the term to a blue wrap top. We got closer, but we're still missing some details. So we had to add another keyword. We made it to a blue stripe wrap top. And now we got really close, but the product we're looking for is still nowhere near to the top of the search result. All through the experiment, there were only 2 individuals who were able to complete the task. One of them worked for the buying office. She actually knew the exact brand name and product name. And of course, I worked. The second one was an engineer from our search index team. The engineer was able to get to the product detail page and reverse engineer a set of search keywords. It goes something like this. Blue stripe wrap top with side tie and double button cuff. The whole point of this experiment is to illustrate. It's not about how well we can actually understand the search keyword. Fashion is all about visual. It has its own set of vocabularies and taxonomy. If a customer has a product in front of them, the best way to help them to find the product in our catalog is actually through visual search. And this is why last year we started working on visual search. There are 2 parts to visual search. Step 1 is object detection. It's all about giving a picture or a frame from a video, understand the object of interest. Once we understand the object of interest, we create a bounding box around it, and then we move on to the next step, which is a similarity search. And then my team and I put a demo together. I'll see if I can play this. So Nordstrom is a 120-year-old fashion retail company, and we started as a shoe shop. So my team and I, we feel it's only appropriate to do the visual search proof of concept with shoe. So you can see we draw the bounding box, we detect the object, and then we send the image to the backend and get the result back. It's really fast. It took about 2 engineers, maybe a month. Hold on a second. Yes, thank you. Our initial implementation of this was entirely open source based. On the top, you can see it's a very typical machine learning pipeline. We start with some simple images, and then we use an open source model called YOLO. It stands for You Only Look Once. Once we train the machine learning model, we convert that to core ML. And then we're able to embed that model into our application. So when we do object detection, it happens on device. It never leaves the device. That's why we were able to really quickly identify the shoe. On the bottom, it's a fairly complex pipeline. We start with ingesting millions of product images into our machine learning framework. And from there, we use feature extraction. We get all the image features out of those images. And then we run that through a clustering algorithm to put product into different clusters based on their visual similarity. And at runtime, once we detect the object, we carve the object from the bounding box, we send it to our backend search API. And then we have to go through the same process, feature extraction, identify which cluster this image belongs to, and then do the product search. We had 2 engineers work on this, probably spent 1 month, and it worked. The whole pipeline was built on top of GCP, and we were able to get an accuracy of 80%. What that means is if we sell this product on Nordstrom, 80% time, we can actually identify it through image. And 80% is actually not good enough. We want to provide the best service and best experience to our customers. However, in order to close the gap, the remaining 20%, we actually had no idea how to get it done or how long it was going to take. So I think it was December last year, we had the opportunity, had the conversations with Google, and we formed a partnership, and we changed our platform to this. The top part, the object detection remained the same. It was a pretty simple pipeline. But as you can see, the complexity that we had on the bottom part, the visual similar search, was entirely replaced by Google Vision Product Search. We simply pass all our images to Google and create a product set images. And at runtime, once we detect the object, we send that object through our search API and then to Google Vision Product Search. It just returns the result. This new design simplifies our architectural design, cut down our service cost, and our accuracy was over 95% on day 1. So there are a lot of benefits switching over to this cloud-enabled platform. Our engineers now can spend more time actually design user interface or better user experience. What we're going to work on next is actually try to figure out how to do multi-object detections. And then from there, we're also going to enable this experience to all product categories. Thank you.
Thanks, John. I think it's incredible to see the innovation happening within Nordstrom. and how this helps you move quicker and get better model performance. Really exciting work. It's been great working with you. I'd next like to invite Kathy DePaolo, who's Vice President of Engineering at the Walt Disney Company. We've had a great partnership with Disney over the past couple of years, and one of Kathy's many responsibilities is building out a personalization and recommendation experience for the Disney customers online and in the parks. Please welcome me in inviting Kathy on stage.
Thanks, Mark. So before we go forward, I want to tell you a little bit about my team and where we sit in the broader Disney organization. So we work on experiences that are both behind the scenes and guest-facing. And we are charged with creating products and experiences that bring our characters and our stories to life. So Disney's guests have deep affinities for our brands and our characters. And it's our job to make our guests feel understood and well served, whether they're in our parks or in our stores. Now, Disney has over 200 retail stores in North America, as well as stores in Europe, Japan, and China. We have over 600 retail locations inside of our parks. And Shop Disney is the e-commerce arm of the Disney store. On Shop Disney, we sell dedicated Disney and Disney Parks merchandise, as well as licensed product from our partners, such as Coach, Dooney & Bourke, and Rag & Bone. The products include franchises from Marvel to Pixar to Star Wars, and really a very broad variety of categories of product. So everything from home goods to toys, collectibles, costumes, etc. So how do we help our guests find what they're looking for? This is where we decided to partner with Google on a data-driven approach. So we were already showing recommendations on our product detail page, which is where you get to if you click into an item on our website. We wondered if we could do better using deep learning models that were personalized with real-time user interactions. So we worked with Google and trained a model using a year's worth of anonymized user interactions. And then we tested. So we tested our old model versus the Google model. Now, you can see the difference here. The old model was keying purely off of product metadata, which frankly can be a little confusing. So the guest search for a sleep mask resulted in the items on the left, which you might not really want to sleep in. On the right-hand side, you can see the Google model figured out that it wasn't just about the mask, it was about the sleep, and suggested much more appropriate items. So the result of our test, which we ran during our busy holiday season, was pretty impressive. Across the board, we saw increased engagement, which is what we were optimizing for, so that was good news. But we also, as a second order effect, saw increased revenue. So we were encouraged by that and decided to try another placement on the add to bag modal. So once you've already clicked on an item and said, yes, I want to add this to my bag, you see a pop-up. And in that pop-up, now you'll see more items that you may like. So again, we tested Google versus the previous recommender. And you can see the example on the left-hand side where, again, we're keying off of the product metadata. So it was a light-up costume, and the recommender picked up on the light and suggested a bunch of lights. Whereas on the right-hand side, the Google model, which was leveraging millions of past user interactions, figured out that these are items that are frequently grouped together and bought together. And so we got much better results. Here's another example where the user was looking for a red dress, added the red dress to their bag. Probably they don't want another red dress. So the Google model figured out that users were more likely to purchase things like shoes and accessories if they had already added a dress to the cart. So in this case, we had not previously been showing recommendations in that placement. And so when we ran our test, we actually ran an ABC test. We tested the Google recommender versus the old recommender versus no recommendations at all, and got some interesting results. The Google recommender did well. The no recommendations test case actually did better than the old recommender. And so working with Google's engineers, we figured out the reason for that, which was on certain mobile devices and certain web browsers, the addition of the recommendations at the bottom of that the modal actually pushed the add to bag button off the screen. So that was a good lesson learned for us, which is it's not just about the model quality. It can be equally important to focus on the placement and the design of how that model is presented to the users. So speaking of lessons learned and takeaways, number one, you guys probably all know, it's all about the data. When we started out, our data was woefully unready for use in machine learning. And frankly, I think the only way to get it ready was to start using it to build models. And along the way, we discovered all sorts of interesting things about our data that had nothing to do with ML, but were actually useful to the business. Placement matters, so the type of model, the design of how it is pulled onto the page is really important. Testing, you really can't know until you get it out there and start comparing live, not just offline models. And then finally, I think as John mentioned, leveraging Google's expertise was really key for us on this. It allowed us to not have to worry about things like scalability, getting that last 10 to 15% of accuracy that we were looking for, and to be able to really put out a high quality product on day one. So happy ending to our story. We're currently running both of these models live in production, and although we're no longer testing, we are seeing increased average order value, units per transaction, and revenue. So going forward, we're continuing to work with Google and seeing many more opportunities for where recommendations and cloud-based ML can have a great impact for us and our ability to serve our customers. Thanks very much.
Thank you, Kathy. That's fantastic. It's great to see how we've been able to partner with Disney to create new experiences on the Shop Disney site, leveraging a lot of our research that we've pumped into recommendation, personalization, and deliver that as a managed service that you can start using today to deliver personalized and recommended experiences for your customers. Next up, I'd like to invite Olga Lagunova, who is the Chief Data and Analytics Officer for Pitney Bowes. Again, another fantastic partnership for the Cloud AI team and Pitney Bowes. Please join me in welcoming Olga.
Hi. I'm going to switch the slides, and it works. Fantastic. So let me tell you what Pitney Bowes is. Pitney Bowes is a global technology company that helps our customers with by providing solutions around commerce. And we serve a large number of customers, from small and medium businesses to 90% of Fortune 500 companies. But one of very important segments of the customers for us are retailers. Our fastest growing commerce services business serves more than 700 retailers, and we are the number of retailers growing every day. So what do we do for these retailers? Well, when Mark was showing you the slide that shows retail value chain, there was little areas there that said logistics, fulfillment, and delivery. And that's what we do. We help retailers with e-commerce, with logistics, fulfillment, and delivery. And Mark also talked about increasing customer expectations. So if you think about your experience on e-commerce side, And when it comes to ordering something, what is your expectation? I want something fast, and I want it free. And if I don't like what I get, I want to return it free. And so this fast and free, and please tell me every single moment of my existence where my package is today, because I like it. Like if I could have an Uber app that shows me how my package comes to me, that would be really cool. That expectation is actually not that simple to accomplish for retailers. So this is where Pitney Bowes come in, and we provide platforms that enable us through the scale, help retailers to accomplish this fast and free delivery and return domestically and internationally. That's what we do. By the way, if you don't know, 90% of us, when you go to the e-commerce site and you don't think that what you see is fast and free enough for you, you're going to leave, which means that a retailer just loses you as a customer, and you may never come back. That's really bad, right? So that's what we want to avoid. This is just an example of some of the retailers, and I'm happy to say that our Nordstrom colleagues are part of it. Today we are going to talk about very specific business, part of Pitney Bowes business for retailers, and we are going to talk about cross-border business. Selling internationally, it's a very big opportunity for retailers. In the United States, about 50% of people who shop online shop internationally. It means that I would buy from China or UK sometime this year. If you are in China, 79% of consumers are shopping internationally. So it's a really great market opportunity for retailers, but it's not that simple to get into this business. There are a lot of complexities. So this is where Pitney Bowes come in. I'm not going to go through this rather complex slide, but I'm just going to mention a couple of things, and I will explain why we are so excited about AutoML. So this business of cross-border shipping is impossible for us to do if it wasn't driven by data, AI, and ML. The efficiencies that are necessary to provide the good value to retailers demand a high scalability in the area of AI and ML and applying it in many, many areas. We are going to look only at one of them today, fraud, and this is where we started testing AutoML tables. But our vision is to continue working with Google so we continue scaling our abilities. Just give you a couple of examples, right? So you come to the website, you got to the localized website that we can help retailers to create, but now you're going to be quoted how much it's going to cost to ship a particular item. And just understanding what this item is sometimes is not that simple. Yes, for retailers with a very good catalog, it's easier. But if it's eBay seller, it's not so easy. There is a lot of natural language processing and a lot of AI and ML behind that, just to understand what is going to cost you to ship. There are customs optimizations that we can do. So we can predict whether we need to check this particular item, open the box and check it before we ship it. Things like that, every single step, the efficiencies are driven through data and very advanced analytics. Part of it, what the service that Pitney Bowes provides to the retailers, is international payments, which has its own set of fraud detection, but also we do additional level of detection on international orders. There is a patterns that you can identify in the behavior based on the history of a particular seller or the history of how the SKUs are shipped to a particular address. Even if we didn't detect the fraudulent transaction through the credit card, you could sometimes see patterns by looking at multiple credit cards buys going to the same address. So there are a lot of things that we do in this area to understand whether the particular order is fraudulent or not. Now, this is where we started experimenting with AutoML tables. Just to give you an example of why it is really important to look at the fraud. Fraud rates rise significantly, constantly. This is a very dynamic and very aggressive part of fraudulent attempts, malicious attempts to attack. And if you look at apparel, cosmetics and perfumes, jewelry, consumer electronics, all these areas that our retailers ship internationally are subject to fraud. And so when we look at this problem of identifying fraudulent international orders, there are 3 goals that we want to accomplish. The first one, obviously, do not let fraudulent orders to go through. That's the most important thing. So identifying correctly all the fraud is important. But also very, very important is not to have false positives. And one of the big motivators for not having false positives is we really do not want to affect experience for the good consumers, right? It's not a great consumer experience, and it's not serving our retail customers well. So we do have a team that goes and looks through orders that were identified as fraudulent, especially if our level of confidence is not high. So this team hopefully is going to take care of the consumer, but also we need to take care of this team, right? It's a manual process. We want to reduce manual process as well. So looking at how we solve this problem, we started with a rule-based system. And this rule-based system helped us to decide which orders are accepted or held for review. It's a third-party rule-based system. It worked for us okay for a period of time, but the rules became increasingly complex, really difficult to maintain, and too slow to adapt to a rapidly changing fraud environment. So we started by augmenting this rule-based system with ML-based models, and it's a constellation of models. The one of them is based on XGBoost, and it trained on fraud labels to score the transactions. And that has been very successful for us. When we implemented it, fraud loss rates reduced by 49%, and review efforts reduced by 14%. So what's the problem? Well, we, over the years, developed a lot of expertise in running production models against e-commerce transactions. We have a really good team of data scientists and ninja engineers who developed a proprietary framework where these models run. We have 20 milliseconds response time on all the calls with the SLAs. We run multivariate testing. We monitor these models very closely because every mistake in the model actually direct hit is definitely on our margins and our profitability for our retailers. But it takes time and it takes effort to develop the models and then deploy them and manage the life cycle of the model. What if we could multiply our ability to bring AI and ML competencies to our business? What would it do for us? I think that it's a tremendous impact for us. And so in this particular model, we wanted to prove that we could use AutoML table to just automate and speed it and get it to the simplicity of a business analyst or our engineer to just create the model and run with it. The deployment is a snap without, like there is no, it just all there automatically happens. So we knew that would be a huge boost. So that's what we did. In addition, we were not necessarily happy with the precision of our model. We had false positives that we wanted to eliminate. And knowing we were very happy to work with Google to make sure that we can take advantage of this Kaggle competition winning kind of quality of the models and see what is going to happen if we're going to apply them to our problem. And that's what we did. So we used AutoML tables. We were one of the alpha users of this technology. We used it with binary classification. And we tested it with and without feature engineering, because a big value proposition of AutoML table is that you don't need to do feature engineering. The promise of it is that you could get the same level of performance from the model even without feature engineering. And when we did that, we proved this is the case. We took the raw data with very minimalistic things that we had to do to remove some PII information. But when we ran AutoML table against it, the performance actually was better than the models that we were using. And not only that, the whole ability to reduce time to develop and deploy model from months to actually now it's just days, as AutoML is getting into the next beta stage and going big. It's a really powerful tool that we hope to make available to our data engineers and advanced business analysts to democratize AI and making even bigger impact on our business and the way we serve our retailers. Thank you.
Thank you, Olga. So we've covered a lot of content today. Hope you'd agree that some of these products that we're bringing to market are really exciting for the retail industry. We really enjoy working deeply with retailers and retail technology partners in bringing this technology into your business. So just to quickly recap, Contact Center AI is using some of our cutting-edge understanding of voice understanding, voice synthesis, real-time production engine to deliver an automated experience for your call center. This is truly a breakthrough capability. We're also using our cutting-edge computer vision technology to enable you to take photograph and search by image. And our recommendation AI product is using all of the research that we've pulled from YouTube and Google Play so that you can deliver a per-user, personalized recommendation experience that'll drive on your business KPIs. And then finally, AutoML tables can tackle a whole variety of business problems for you, whether that be forecasting how much product you now need to have in every store, or whether it is detecting fraud or understanding the likelihood of a customer to buy a specific product. So if you've got any questions and you're interested in talking about this further, I'm going to be on the side of the stage, but I'd also recommend that you take down this email alias here, which actually connects you to product managers, engineers, and people inside of Google that would love to talk to you more deeply. I will say that this is just the tip of the iceberg. We have a big team focusing on retail, and it's our commitment to you that we're going to be bringing more AI capabilities to the retail industry over the next year, 2, 3, 4 into the future. And we're really looking forward to working alongside you, such that you choose GCP as being your platform of choice, leveraging its capabilities and all of the other stuff that we've talked about at this conference. So I'd like to thank the speakers for joining me on stage today, and thank you all for joining us.